Welcome to this video. So in this video, we are going to solve questions involving the normal distribution. Okay, so let's start. So the first question, they're saying the birth weights, W grams of a particular breed of kitten are assumed to be normally distributed with mean 99 grams and standard deviation 3.6 grams. So I've been told that the mean is 99 and then the standard deviation is 3.6. Right, so now let's look at the questions. So the first question, they're saying, find the probability that W is greater than 92. Okay, so the first thing, we just have to standardize this W. So in this case, the Z-score will just be W minus the mean divided by the standard deviation. Okay, so let's standardize it. So we're going to have W minus mu divided by the standard deviation is greater than 92. Okay, so this is our W minus the mean, which is now 99, divided by 36. Okay, so this will be the probability of this becomes Z, okay, is greater than, and then here we have a 92 minus 99, that is minus 7, and then minus 7 divided by 3.6, okay. My calculator is showing me minus 1.94. All right, so we have to convert this guy, okay? We see we have a greater than here, but when finding Z probabilities, we always have to have a less than there. So we can convert this using what we know as the complement rule. So this whole thing here is the same as 1 minus the probability that Z is less than minus 1.94. All right, and then from here we can find the value of this. Okay, so we're going to say 1 minus, okay, and then the probability that Z is less than minus 1.94, we can find it on the Z-score table. So let's go on the Z-score table for negative values. Okay, so this is the Z-score table for negative values. So we are finding the probability that Z is less than minus 1.94. So it means the 1.9, we're going to find it in this column. And then the 0.04, we're going to find it in that row. So the 0.04 is just there. Okay, where is the minus 1.9? So minus 1.9 is where? It's here. Okay, so I'm going to go to the right side here, like this. Okay, and then from here, I'm going to go below like that. So where they are meeting here, that's the probability that we are going to what? To get. Okay, so that is the probability there in the box. So that the probability is 0.0. Okay, so 0.02619. Okay, so that's the probability that I have there. So I can go on and write it here. So it would be 0.02619. Okay, like the Rema still, right? Okay, so now we can calculate this from the calculator. Okay, so this will be 1 minus 0.02619. Okay, so 2619. So I'm finding the probability to be 0.97381. Okay, so that would be my final probability that I'll find there. So this is the probability that W is greater than what? 92. So here I used the complement rule, right? Okay, in changing this guy, the greater than to a less than. But if you want, you can use what we call the symmetric rule. Okay, so if I have probability that Z is greater than minus 1.94, this here is the same as the probability that Z is less than the positive value of this. Okay, so you can use this one or this one, you're still going to get the same ones. So now this is 1.94. So we are using the positive Z scores. So if I go here, on the positive z-score, I'm finding the probability that z is less than 1.94. So 1.9 to be in this column, so it is there. Okay, and then the 0.04 to be there. So I'll come down here like that, and then from here I'll go to the right like this. So this here will be my probability. You can see that the probability is the same that we found. Okay, so we can go back here and write it. This is the same, 9, 7, 3, and then 8. Okay, of course, you can put the 1 there if you want, or if you want, you can put. Okay, so this is 9. So the probability is the same. Either you use the symmetric rule like here, or you use the what? The complement rule. All right, so now let's move to the next question. Okay, so the next question, they're saying find to one decimal place the value of k such that the probability of W being less than k is equals to 3p, okay, is equals to 3 times the probability of W being greater than k. Okay, so the first thing is to standardize these things. Okay, so we're going to say probability. If I standardize W here, remember Z is equals to this. If I standardize the W, it's just going to get Z less than K minus the mean, which is 99, divided by 3.6 is equals to here. Okay, here I'm going to say I have 3, okay, and then probability that if I standardize W, I'm going to get Z is greater than standardize K to be K minus 99 divided by 3.6. Okay, so what I need to do here is to eliminate, okay, or to manipulate this greater than here. So this will be the same as probability that Z is less than K minus 99 divided by 3.6 is equals to 3. And then this part here, the probability that Z is greater than this, okay, we can write it as 1 minus the probability that Z is actually less than this. Okay, so we always change any greater than to a less than. So this will mean that, what do we have there? Okay, so I can erase what I have on top. So it means that what we have here is just probability that Z is, probability that Z is less than K minus 99 divided by 3.6, okay, is equals to, here we can multiply the 3. So it will be 3 minus 3p Z less than K minus 99 divided by 3.6. So this is what we have. So we see that we have the same things here, okay? This part is the same as this. So we can do like terms together, okay? So this guy here will follow the other guy to the other side. So this is minus 3p, and then this is, this is minus 3, and then probability of this, and then here we just have probability of that. So when this minus 3 goes to the other side, it will be plus 3, and then the probability of this. So we add that. So this will be 1 plus 3. So that will be 4p. And then K minus 99, 3.6. Okay, is equals to, we're just remaining with 3. So we just want to remain with the probability. Eh? So probability that Z is less than K minus 99 is equals to, so I divide both sides by 4. So what is 3 divided by 4? 3 divided by 4, it is 0.75. Okay, so for me to find the value of this K, I just have to find the Z-score value that corresponds to the probability of what? 0.75. Okay, so I go on the Z-score table and then I look for this probability, okay, or a probability that is very close to it, and then I get its Z-score. Right, so let's go to the Z-score table. That should be for positive values. Okay, so I'm looking for the probability 0.75. Okay, so 0.75, it's somewhere where, okay, so 0.75 should be somewhere here. Okay, 0.75 should be somewhere where. So a number that is very close to 0.75. So we can look at this number and also this number. and also this number. So which one is very close to 0.75? Okay, so this one here looks very close to 0.75. Okay, or we can just count the units, but by how many units uh, does it have to gain or lose for you to have 0.75? Okay, so you can get your calculator and then you try to subtract. So if I look at this one, okay, if I do 0.75 minus that number there, which is 0.748 57, okay, I'm getting 0.00143. Okay, if I use this one, what if I use this one? That one I'll get 0.0 0.00175. So how am I getting this? I'm just doing this number since it's bigger than 0.75. So it's this number minus 0.75. This one was smaller, so I do 0.75 minus this. So I get this difference, this difference. What about this one? Okay, so 0.75 minus 0.74537. I'm getting 0.0043463, 463, I mean. So between these three numbers, which one is smaller? Okay, we see that the one which is smaller is this one. So it means this number here is the one which is closest to 0.75. So we are going to get it. Okay, so we're going to get this number and use it to find the z-score. So if I go up, I'm finding 0.07. And then if I go to the left-hand side here, the far end there, I'm finding 0.6. So I add 0.6 plus 0.07. I'm going to get 0.67. Okay, so this is the z-score. The z-score that I'm going to use here. Okay, so for me to have this probability, it means that the z-score here should be 0.67. So I'm going to equate this to this, and then so for the value of what? K. Okay, so what we have now will be K minus 99. 3.6 is equals to 0.67. Okay, so now let's just do some calculations there on the calculator. Okay, so this will be what now? Okay, I can erase this part. So this will be K minus 99 is equals to this multiplied by this. Okay, so we have 3.6 multiplied by 0.67. So this is 2.412. So K will just be 99 plus 2.412 is equals to, so plus 99, I'm getting K to be 101.412. Okay, but remember, the question said we should find K to one decimal place. So we can round this off to one decimal place. We get 101.4. Okay, so that's it. We found the value of K, 101.4 to one decimal place. Right, so we're done with the second question. Let's look at the third one. Okay, so the third one, they're saying, for a different breed of kitten, the birth weights are assumed to be normally distributed with mean. Okay, so now here it's a totally different question because we have another mean with mean 120. Okay, okay, so they're saying given that the 20th percentile means 20%. Okay, and 20% is the same as 20 over 100, which is just 0.2. Right, so given that the 20th percentile for this breed of kitten is 116, find the standard deviation of the birth weight of this breed. Okay, so what they're telling us here is that the probability, okay, that W, which is the birth weight, is less than 116 is just equals to what? 0.2. Right. So now, we want us to use this information to find the standard deviation. because here they've given us a new mean, which is what? 120. So if we standardize this, okay, if I standardize W, remember Z is equals to W minus mean and then standard deviation. So if I standardize the W, I'm just going to get Z less than 160 minus the mean, which is 120, and then the standard deviation, I don't know, is equals to 0.2. Okay, so it means here we need to find the Z-score that we can put here so that uh, the probability should be 0.2. Okay, so we do like what we did here. Okay, so we go on the Z-score table, find the probability that is very close to 0.2, and then get it's what? Z-score. Okay, so let's go to the Z-score. So this is 0.2. So the 0.2 will be found on the negative Z-score table. Okay, so where is it? Okay, so it won't be found here because this one is, oh, yeah, it's found here actually, because this one is the negative one. I can see negative, negative here. So we are looking for a number that is very close to 0. What? 2. Okay, so a number that is very close to 0.2, where can I find it? So you just look for a number that is very close to 0.2 here. Okay, so which one now? Okay. So let's try this one. Okay, so this one here is the number that is very close to 0.2 of all the numbers here, because this one is above 0.2 by 45 units. Okay, this one is below 0.2 by a lot of units, and this one is above 0.2 by 327 units. So meaning this one is the closest. So I go up, I get the 0.04, and then I go to the far left, I get the minus 0.8. So it means the Z-score there will just be minus 0.8, and then this one also is a minus, so minus 0.04. So this will just be the Z-score, just be minus 0.84. Okay, so this is the Z-score, minus 0.84. Okay, so I go back here now. Where is it? I can put it here. So it means here, this one is equals to 0.84. Right, so from there now we can find the standard deviation. Okay, we can find the standard deviation. So we're just going to say 116 minus 120. Standard deviation is equals to minus, like that. Okay, so when I subtract 116 minus 20, I get minus 4. This is equals to 0.84, which is a minus. So this is minus 4 is equals to minus 0.84 sigma. Okay, so we can divide both sides by 0.84. So sigma, which is the standard deviation, is equals to minus 4 divided by minus 0.84. So this one is going to give me what now? So just go on your calculator and then you punch this. Okay, so we have minus 4 divided by minus 0.84. So I'm getting my sigma to be approximately 4.761904761. Okay, we can round this off to okay, we can round off to 4 decimal places to be 4.7619. Okay, so this one will be our standard deviation for the birth weight of this breed. So we are done with this first question. We look at another set of questions. Okay, so now they're saying a machine, okay, a machine fills bottles with water. The volume of water delivered by the machine to the bottle is X milliliters. Okay, where X follows a normal distribution with mean mu and variance, variance sigma squared there. Okay, one of these bottles of water is selected at random. Given that the mean is equals to 503, okay, and the standard deviation is 1.6, find the probability that X is greater than. 505. So we see a greater than here. We have to change it. So this is x greater than 505. We have to change it to 1 minus probability that x is less than 505. And then now we standardize this probability. If I standardize x, remember z is just equals to x minus mu divided by standard deviation. If I standardize the x, I get z less than 505 minus, what is the mu? 503 divided by standard deviation 1.6. So here we have 1 minus the probability that z is less than. So here 505 minus 503 is going to give me 2. 2 divided by 1.6 is going to give me 1.25. Okay, so that's the probability that we are finding there. So let's go to the z-score tables and find that value. So this will be equals to 1 minus the probability that z is less than 1.25. Okay. So we're finding the probability that z is less than 1.25. So the 1.2 will be in this column. The 0.05 will be in this row. So 0.05 is there. 1.2 is where? Here. So I go to the far right, and then I come down like this. So that is the probability there. Okay. So 0.89 and then 435. So we can round it off. We can say 0.8944. So this will be 0.8944. So subtract, we're going to get 0.1056. So this is the probability that x is greater than what? 0. I mean z is greater than 505. Okay. All right, let's look at the other one. Okay, so the other one, what we have is they're saying find the probability, okay, that x is between 501 and then 505. Right, so this here is the same as probability that x is less than 505 minus probability that x is less than 501. So now we can standardize this. This will be probability. If I standardize x, I get z. And then this one, it's just 505 minus the mean, 503 divided by 1.6 minus probability z. Okay, 501 minus 503 and then 1.6. Right, so this will be probability that z is less than 505 minus 503 is 2 divided by this. I get 1.25 minus probability that z is less than 501 minus 503. That will be minus 2. And then divided by 1.6, I get minus 1.25. Okay, so that is what I have. Okay, so we can go directly to the tables. Okay, you go to the positive z-score, you find this probability. You also go to the negative z-score, you find this probability. Okay, so let's find this probability from the z-score. We're just from finding it when we're finding this. Okay, we found that that probability was simply 0.8944. And then we're going to say minus, and then now we can struggle with this one. So we go to the negative z-score table. So we're finding the probability that z is less than minus 1.25. Okay, so if I go here, I have to look at this negative table. Okay, so we're finding the probability that z is less than minus 1.25. Okay, so minus 1.2 will be in this column, and then the 0.05 will be in that row. So it's there. Then minus 1.2 is there. So I go to the far right like this. Okay, and then here I come down like that. All right, so this is the probability there. So the probability there, okay, is what? Let me raise this line inside. It's 0.1, okay, 0.10565. So we can round it off to 0.1057. Okay, so it's the one that we're going to use. So I'm going to write 0.1057. 1057. Then I can subtract these on the calculator. So my final answer will be, okay, so it will be 0.8944 minus 0.1057. So I'm finding 0.7887. So this is the probability, okay, that x will be between that x will be between 501 and 505. Right, so we are done with that question. Okay, look at it. 2. Okay, so 2, what do we have? The same, find W just such that the probability of 106 minus W, okay, W is equals to 0.9426. So I want to find the value of the W there. Okay, so what do we do? Same thing, we just have first to standardize this thing. Okay, first have to standardize this thing. Okay, so standardizing, remember that our mean is this, our standard deviation is this. So it will be probability. Okay, so this one will be 106 minus W minus the mean divided by standard deviation. Standardize the X to be Z. This one here to be W minus 503 divided by 1.6 is equals to 0.9426. All right, so let's subtract. So 1006 minus W minus 503. I'm just going to get 503 minus W in the 1.6 less than Z less than W minus 503 over 1.6. And this is equals to 0.9426. Okay, so this is what we have. Okay, so we can play around with the complement rule and the symmetric rule. Okay, so this here simply means probability of Z being less than this 1.6 minus the probability of Z being less than this. Okay, so now by symmetry, if I have probability that Z is less than a certain number, let's say A, this here is the same as the probability that Z is greater than the negative of this number, which is minus A. So that's what I'm going to use here. Okay, so I'm going to say probability, this one is just the same, over 1.6 minus, so this one here, I'm going to write it as probability Z is greater than, and then I'm going to introduce a negative here. So if I introduce a negative there, it will be something like this. So this negative will multiply what is above there. So it will be W minus 503 divided by 1.6. Okay, so this is what I have now. Okay, so I'm doing that so that it should be the same with this guy here. Right, and then from here, I'll use the complement rule. Whenever I have a greater than, I can write that as the, okay, so this one is still the same. Okay, but here, this one will be 1 minus probability, that's Z, is less than W minus 503 divided by 1.6. Okay, so this is what we have. So now we see that this part and this part, they're exactly the same. So we can distribute this negative, so it will be -1, and then plus this. So it will be plus this, plus that, to just be 2 of them, right? Okay, so remember that this probability is equals to this. Okay, so sorry, I've ignored it, but here we're supposed to write is equals to, and then we put this. So this one here, Okay, when I distribute this negative, it will be 2 probability of Z less than W minus 503 1.6 is equals to, minus 1, okay, because this will be minus 1 is equals to this probability here. Okay, I just forgot to write it here. Okay, so this is what we have there. Okay, so this will mean we have 2 probability Z minus 3 minus 503 1.6. So this one goes to the other side. So it will be 1 plus this. So that is 1.9426. Divide both sides by 2. Okay, so if I divide that number by 2, what do I get now? Okay, so I get 0.9713. Right, and then from here now, it will be very easy to find the value of W. So what we need to do there is to find the Z value here such that we have this probability. So we'll go to the Z-score probability for the positive values and search for this probability and then get its Z-score. So that Z-score will be equals to this. Right, so let's go. So we are searching for what probability? We're searching for the probability of 0.9713. So we are looking for a number that is close to this or the exact number. So 97, 97, 96, we have 96 here, 97, that started there, 97, okay, so it's here. So this is 0.97128. So if we round it off, we have our 3 there. So I'll go up, that is 0.00, and then if I go to the left, that is 1.9. Okay, so that would be 1.9 plus this, just 1.9. So it means this part here is equals to 1.9. Okay, so we can find our W now. So we're just going to say W minus 503 over 1.6 is equals to 1.9. Okay, so this is what we have there. So let's multiply is equals to, this will be 1.6 multiplied by 1.9. Okay, so 1.6 multiplied by 1.9, what are we going to get? So multiply that on your calculator, we have 1.6 multiplied by 1.9. So 1.9.0, it will give me 3.04. And then this will be W is equals to 503 plus 3.1.04. So let's add this now. So if I add this, I'm getting 506.04. So this is the value of the W such that this is what? True. Right, so we are done with this question. Okay, let's look at the last question here. Okay, let's look at the last question. Right, so it's the same things. So they're saying in a population, suppose that the mean resting body temperature is 98.25. Okay. Fahrenheit, okay, and the standard deviation is 0.73 degrees Fahrenheit. The resting body temperature are normally distributed. Let X be the resting body temperature of a randomly chosen individual. Find the probability that X is less than 98. So the mean is what? 98.25, and then the standard deviation is 0.73. Right, so probability that X is less than 98, it's the same as probability, standardize the X, that will be Z, then this will be 98 minus 98.25 divided by 0.73. Okay, so this will be Z is less than. So if we standardize that, that will be, okay, let me punch it on my calculator. Right, I'm getting minus 0. minus 0.34. So I round it off to 2 decimal places because that's what I can see on my Z-score. Okay, so what is the Z-score of this guy? So you go on your Z-score table for the negative value because this is negative. Okay, so I'm finding the probability that Z is less than minus 0.34. So here I'm looking for minus 0.3. So minus 0.3 will be there. And then here on the column, I'm looking for 0.004. So it will be there. So I come down here. And then here I go to the far right like this. So where they cross, it is that value. Okay, so that's the probability there. So 0.366, 0.36693. Okay, so that's the probability that I'm going to get. So I can go back here and write 0.36693. So the value might be slightly different depending on the table that you are using. Okay, but that's the value that I'm finding there. So that's the probability. Okay, and then for this other question, we do the same. All right, so we are finding the probability that 98, okay, 100. So this we can standardize, so it is 98 minus 925 divided by 0.3 less than, standardize the x, you get z, 100 minus 1, okay, 0.23. Okay, so now this one here, I'm going to get minus 0.34 less than z, okay? And then this one, if I punch it into my calculator, I'm getting 2.40. Right, so this one means it's the probability that z is less than 2.40 minus the probability that z is less than minus 1.34. Right, so you can get these z-score values from the z-score table, okay? This one from the negative one, this one from the positive one. So I won't show that, okay? But when you do that, what you get is this. So the probability that z is less than 2. The probability that z is less than 2.40, okay, is simply 0.9917. So please confirm, or a number that is very close to this minus this, the other probability here, we already found it, okay? It was 0.36691, something like that. Let me check this one here. What was it? Hey, was it here? No, the other side. This one, 0.36693. Okay, so there's 3 at the end there, not 1. All right, so we can subtract this on the calculator now. Okay, so let me do that. So 0.9917 minus 0.36693. So I'm finding 0.62477. Okay, so this is the probability there that I'm ending up with. All right, so we solved the last question in this video. Okay, so the last question, they're saying find the 0.9 quartile of the distribution. So it means that the probability of x being less than a certain number x, okay, is actually equals to 0.9. So let's standardize this. We're going to get z less than x minus 98.25 over 0.73 is equals to 0.9. So we're just looking for the z-score that will give me the probability of 0.9. Okay, so the z-score that will give me the probability of 0.9 is what? So you go on the table here. So 0.9 can be where? Okay, or a number that is very close to 0.9. Okay, 0.9. So 0.9. Okay, so this number, maybe this one. Let's look at this one here. So this one, okay, how many units does it need to be 0.9? Okay, as compared to this one and maybe this one. Okay, so to find the one which is close, okay, just subtract or add. I mean subtract, not add. So this number here is less than 0.9. So let's find the difference. 0.9 minus this number. So 0.9 minus 0.89796. So I'm getting 0.00204. Okay, so that's what we have. And then what if I subtract this one? So that is 0.899. Okay, and then I have 73. So I'm getting 0.00027. Okay, so we can see that this one here is the smallest difference because that one is going to give me 0.00147. So this one is the smallest difference. So it's this one, this number here, is the one which is closest to 0.9. So I'll go up, I get 0.08, and then I go this side, I get 1.2. So 1.2 plus this, I get 1.28. All right, so that's what I'm going to put here. So this one is equals to 1.28. So I can find the value of the x, which will be the 0.9 quartile of the distribution. Okay, so it will be x minus 98.2 over 0.73 is equals to 1.28. Okay, x minus 98.2, and then let's multiply. So 0.73 multiplied by 1.28. I'm getting 0.9344. So this will be x is equals to 98.25 plus 0.9344. So let's add this plus 98.25. So I'm getting 99.1844. So this one here will be the 0.9 quartile there. All right, so we're done with these questions. Okay, so if you're interested to access the full video, okay, from the tutorial sheet where I was getting these questions, feel free to register with us by using the link in the description there. Okay, so you find a link that shows you how you can register, and then you also find the link to our website. Okay, so I got these questions from two tutorial sheets. One is from this tutorial sheet from Unidas. Okay, so models and normal distribution. So if you would like to access the full video to all these questions that you can see here, okay, feel free to register in the description there. You'll find the solutions to all these questions here. All right, and then if as well you're from Apex, I got some questions from a tutorial sheet as well. So I've solved the questions in all the questions in this tutorial sheet. So all these questions here, they are available on our website. So you can check them out, okay? And then you can learn fast and learn easily. All right, so this has been Tutor Poor Solutions. Thank you so much for watching. Please remember to subscribe and hit the notification bell so that when I post a new video, you're the first one to get notified.